Hi guys, so today we're going to be looking at the uniform search algorithm. So this particular algorithm is called a greedy algorithm and there's a reason. So let me just start the iteration one. So at the first iteration is going to this is visited and this will be the key. So the key starts with arad A. Now it's going to be short. Arad is going to get visited and then we're going to add all the neighbors of arad. So A, and then its neighbors is S, Timosura and Zarin. So I'm just going to represent them as S, T, and Z. Now between these three, we're going to check for their value. So this is 114, 118, and 75. Whoever is the least person, we're going to follow that. And in this case, it is Zarin. So we're going to move on to Zarin. Now you're going to really see the grid in this particular algorithm. So A, we're going to visit Z, so Z. We're going to add the neighbors of Z. S and T are still there. They don't leave. They're still in the queue. The new neighbors are Aradia and Arad. Now, to get to Aradia, it will be 75 plus 71, which is 146. And then to get to Arad, in this case, it will be 75 plus 75, which is 150. And you can denote it as A to Z to Arad, A to Z to Aradia. Sometimes I do just so I don't confuse myself. Now, I want to move on. We're going to check who has the least no value here. Timosura has the least value. You know this algorithm is going to jump back to Timosura. That's why it's least value. So this algorithm is always looking at who is the closest to me right now. When I add all of this up, who happens to be the closest to me? If it finds Timosura to be the closest, it's going to move there. So for iteration 4, it's going to move there. For iteration 4, it moves there. So the neighbor we visited just now was we're going to visit Timosura. In this case, CB is still there, it hasn't moved on. We're going to expand the neighbors of Timosura, which is Arad and Lukosh. So Arad and Lukosh. So we're going to write already the ones that are still here. Then we're going to add these new neighbors, which are Arad. I'll write Lukosh first, so that we don't get confused, and then Arad. So in this case, Arad is going to be 118 plus 118, which in this case is 236. We can just write A to T to R so that we can really differentiate from this R. This was R is 215, it's 246. A to Z to Ardia and this A to Z to R. Next, Luggage is simply 118 plus 101. That would be 111, sorry. Have it 229, so that's A to T to Luggage. Next thing is algorithm going to do is going to compare their values. Guess who's the youngest now? CB is actually has the lowest value here. So it's actually going to move over to CB. So you see why they call this the greedy algorithm. T and CPU. Now we expand CPU's um neighbors, which are first we write these ones already here. Radia, Arad, plus 146, 150, the good and Arad, 256, 229, and then these two new, actually four. That's made up of art again. I don't write art first, but I don't get confused. Baccaras, Meridia, Arvilia, and Losas art. So in this case, to get to Paragas, it's simply going to be 140 plus 999. 169. I'm just going to denote it as Arad to CPU to Paragas. Next, for Iridia, it's going to be 100 plus 151, so that's 291. That's R2 CBA2 Iridia. Next, we're going to have our Vilcai, which is A to S to Vilcai. And that'll be 140 plus 18, that'll be 220. That's plus 18, not 18. Then lastly is Arad, which is HS, so particular Arad. That'll be 140 plus 140. And you simply get your answer as 280. Now we're going to look amongst these three. Who is the lowest? In this case, we find out that this Oridia, which is going from Arad to Zerinch to Oridia, this is the lowest in this particular scoreboard. Therefore, guess what this algorithm does? It's going to move back to Zerinch, Oridia. Let's move back to Zerinch, Oridia, because that's who it finds to have the lowest score. That's who it finds to be the closest person to it. So this algorithm is very greedy. It doesn't commit. It jumps from one place to another. Thank you for listening.